First of all, I've got a question for all of you. I mean, we're thinking about electrification here. We're thinking about, obviously, agricultural machinery and the challenges around that. So, without further ado, I just have a setup question for all our panelists, which is, what, in your opinion, is the biggest single challenge in designing and/or building electric vehicles for agriculture, and why? So, if we go down the line in turn, and we can, if you introduce yourself and then answer the question, and then we'll go from there. We'll try and keep this quite a free-flowing discussion. We don't have I haven't structured it too much, so we will be inviting questions from the audience later on. So we want to get everyone involved if you're interested. So, Markus.
Yeah, thank you. Yeah, my name is Markus Plassmann. I'm from Danfoss, and I mean, one single challenge is for sure the charging infrastructure. I mean, like in urban areas, for sure, you have often charging, but then in ag, I mean, you're in remote areas, and therefore charging is a topic for sure. Then we are seeing also TCO as a topic. I mean, like a total cost of ownership and business case. So electric machines might become more expensive. Therefore, I mean, rethinking the architecture chosen. I mean, small machines often operate battery electric, then bigger ones we see hybrid architectures, and then efficiency is a big topic. So really thinking about the TCO, what the right system is, and then how to also reuse kind of energy from your farm and so on. So kind of rethinking the full TCO.
Excellent, thank you. So, moving on, Steffen, the view from Bosch Rexroth.
So, my name is Steffen Mutshler from Bosch Rexroth, and the current view is that the major challenge of reaching the energy density for batteries to move really to the field is beyond. What we need to focus on now is to electrify everything that is close to the farm, to be able to use available solar power and energy structures. However, the big challenge here is to create the business case for the farmer, involving not only the machine, but also the complete, let's say, energy provision system in his environment.
Excellent answer. We have another Markus from ACGO Power. On to you with the same question of the challenge that we're facing. What's the biggest challenge in your mind?
Yeah, so it's not only electrifying, it's all the alternative power sources, is how to get enough of energy on board, on tractors especially, or combine harvesters. So it will be high average powers, long working days. So that's the crucial question, that how can we cover the needed amount of energy on a day to do the daily work of a farmer? So that's the key challenge at the moment.
Excellent. Shaun, moving on to you from the OEM side. Merlo has some electric machines in its lineup, and a growing lineup. What do you see as a challenge? You're getting them out there already, but there are still challenges in this.
Yeah, I mean, we're not newcomers to the electric world by any means, but I think one of the biggest challenges is in agriculture is the lack of consistency of application. So, you know, while a tractor might work in one consistent direction, a telescopic material handler works in various directions under various loads throughout the day. And that lack of consistency across the globe in different applications, in what's particularly a harsh environment, throws a lot of challenges into developing a product that can give a decent work cycle and a sustainable life pattern.
Excellent. And finally, Mourad, at the end, from Delta Q, you're on the battery side of things, I believe.
We are on the electronic components part of this. I am from Delta Q Technologies, which provide chargers, either on board or off board, as well as we work with a variety of battery companies. I'm focusing here particularly on battery-powered machines. One of the challenges that's facing electrification is the power density of the battery pack that need to go on these machines because of the variety, because of the big machines, as well as the charging infrastructure that need to be available there, and also enabling fast charging on the different machines.
Yeah. There's we're getting some similar overlapping ideas and trends here that we're seeing. But it is nevertheless, this is a trend that is undeniable, and everyone's here in the room, so it is something that people want to know about. Electrification obviously happening across automotive and maybe more so in there, more so in construction, but we have some unique challenges in the agricultural world. So I was going to ask one further set question before we get into a bit more of a discussion. Just to give, we're not trying to be totally promotional or anything here, but just to get a really good idea about the specialities of the experts that we have here and the solutions that they offer in this zone. So for you, Markus, what are the solutions that your company particularly offers that can be used in electrification or alternative fuel vehicles?
Yeah, so we are now in the market since with electrification since many years, and we try to offer the full scalable portfolio when it comes to electrification. So motors, inverters, and also high voltage DC-DC, and also active front ends to connect machines to a grid when you have stationary machines and so on. And then we now try to build on the components also subsystems, meaning for propel, like e-traction systems with mechanical parts, gearboxes, and then also we are seeing now the big trend is e-hydraulics, because that's what we have in-house, kind of the full hydraulic portfolio, electric portfolio, to combine that system and then to improve efficiency on a machine level. And we also show here a new onboard charger, high power onboard charger, also used as AC EPTO to power some functions, and an extended low voltage range now for the small machinery on the farms.
Yeah. Those onboard chargers are vital to get your charging done efficiently.
Yep.
But at Bosch Rexroth do a whole range of stuff. What can we pick from the portfolio particularly?
Let me keep it short.
Yeah.
As Bosch Rexroth, we are a solution provider. So what we do is that together with the customer, based on our application knowledge, we create efficient machine solutions based on our hydraulics, machine control solutions, and our full electrification portfolio that we have available by now. Yeah.
Excellent. ACGO Power, some alternative fuels as well, as you know, with electrification in the future, some stuff going on. I'm preempting what you're going to say, but tell me what is available from ACGO Power in this field.
Yeah, to fit this headline of today's discussion, so we have just introduced here in this Agritechnica 25 our modular battery pack concept, which we could use for different sizes of agricultural vehicles, provide different capacities and voltage ranges needed in our applications.
Excellent. Something that Shaun might be interested in, and they're designing their next range of vehicles, perhaps. Who knows? But what you obviously offer the vehicles themselves, and a whole range of vehicles, growing range of vehicles.
Yeah. So we've been in the EV marketplace now since late 21 with a fully commercial viable machine that's working, giving an 8-hour work cycle from a single charge. So it's from our perspective something that we're gaining experience all the time. I think as you enter any new development, new sector, every day's a school day, as we like to say. And it's very much a learning curve for us, but we're providing the end customer with an emissions-free solution to handle their material handling tasks, just as they would with a fossil fuel derivative as well.
Excellent. And finally, Mourad, Delta Q. Tell me about your solution.
Delta Q is part of a bigger group, which is the Zapi Group, which is a group of 11 different companies. We do provide all systems for electric machines, and mostly focused on off-highway. Agriculture is one of them. We provide motors, electric motors, DC motor controllers and inverters, DC-DC converters, as well as battery chargers. So we provide all the powertrain components except the batteries themselves.
Yeah, thank you. So just to pick up on one of the themes that you mentioned about AGCO's new battery system, and it's modular, you say, so you can stack different batteries on. This is something I saw on the first day here, John Deere's concept electric tractor, and their battery system was, one of the things was you could stack, the farmer could choose how many battery packs they put in their vehicles. Do you think that's going to be something that's quite important as we move towards electrification in vehicles like tractors?
I think it is, because you have different needs in different farms, and that really makes sense that you can adapt your battery capacity based on your needs and not to pay extra for something you don't really need. A bit the same as with the passenger cars. You have many models offered with different battery capacities, and you can select based on your own kind of an operation profile that this fits my targets, this fits my purpose. So it can be the same in the tractor world, that you can really find out what exactly fits your needs.
Driving down that total cost of ownership, making it more affordable, and if you just need a small battery, that's good. And you were talking, I think, about total cost of ownership as well, about making those parts more affordable and having the right onboard chargers to make sure that. Does that mean that an onboard charger basically helps the thing to be charged much more quickly? That's the main aim of that.
Sure. I mean, onboard chargers to charge on board. I mean, and we have a higher power. It was mainly first done for a truck. We need overnight charging. You can also charge your full truck full loaded. But we also now see many use cases in other applications in off-highway and battery packs. No, but I mean, TCO is really linked to also if the invest is higher for the machine, the vehicle, then you want to optimize your OPEX, also your operating cost. And therefore, it's really down to system efficiency. Look into the optimization, look into recooperation to also reuse hydraulic energy of your system and so on. There's a lot of innovation we are seeing.
It seems a challenge. Shaun, your telehandlers are obviously for both construction and agriculture, and they're used in both. But it seems like at iVT we cover both sectors, and there's a lot of you go to Bauma and every OEM has a mini electric excavator. Every OEM, and some of them are getting bigger and bigger. But in agriculture, it seems a little bit slower. It's not like every OEM has a mini electric tractor. Why is that? Does anyone have any thoughts? This is a sort of open question. Does anyone want to jump in on why electrification is maybe going a bit slower in agriculture than in construction?
Yeah, I mean, just one. Maybe it's also because it's more owner-driven. I mean, the farmers are the owners of machines, and now you have the first generation of electric machines in the market. Maybe it's a bit uncertainty also about invest and then what the machine will be still. What the value will be in a couple of years and so on, compared to like a rental company where you not own the machine.
There's a degree of legislative pressure in construction. So a lot of cities with clean air zones require that construction sites have a percentage of their fleet running on zero emissions. So, there's legislation driving that in construction. We've yet to really see that pressure in agriculture.
Yeah, but there's that could well come, right? If that would seem to be the trend.
I personally believe that pressure could come from the supply chain, the supermarkets, the buyers with their environmental policies, and they want to link to the consumer that's very environmentally conscious. I can see them starting to push on the farmers to really audit their business in environmental.
Do you find that you're selling those electric telehandlers to farmers who are, the chain is, the supermarkets want it?
You generally find that a farmer that's willing to invest in an electric material handler already has invested on-site generation. So whether that's solar PV or whether that's a wind turbine, he of course then has on-farm his own source of energy.
Yeah, we've got two. You said first, and we'll come to you.
Thanks. So basically what we're talking about in the end is the business case. So we need to create the business case for the farmer that makes it attractive. And this business case can either come, let's say, from selling the products as bio products produced zero emission, or they can come, let's say, from reasonable business cases with respect to electric power. Yeah. So thinking about a farm, not only about a production site for food, but also as a production site for electricity, like we're saying, with respect to solar power, with respect to wind power. Yeah, marketing this, let's say, in an approach together with electrification companies, or say electricity companies. Sorry. Yeah, going into direct marketing, selling at the right time, using the additional storage capacities you have in your electric equipment. Yeah, to store the energy during sun time, during noon time, when there's a lot of electricity available, selling it directly to the electric market, maybe during the night, when there's not so much solar power available. Yeah. So thinking about these business cases, how to make electrification on the farm in general more attractive.
And maybe making new partnerships with these with these companies, with the solar companies? Or?
So in the end, you cannot leave the farmer alone on such a complex topic. Yeah? He is worrying about, let's say, his crop. He is worrying about the solar panels on his roof. But connecting this all with an electric machine and then connecting it to the electricity stock market, yeah, it's getting very complex. So what we need here is really attractive business models, bringing this all together in one approach.
Yeah, it's a very good point. Mourad, you had a point as well.
Yes, I would like to add a few, 3 more aspects actually to what has been said. The first one is where we see more electrification in machines that are used in urban environments. So, for example, like the micro tractors for green maintenance, for green spaces. The second one is actually using the machines in indoor environments such as horticulture or greenhouses or feedstock production. And the last one is automation and robotics that is propagating more, and it happens more and more on the smaller machine, compact machines. That's we see a lot more electrifications than on the bigger field and crop production machines.
Yes, yeah, that comes on to, did you want to interject there?
Yeah, maybe adding to both of these comments, or all of the comments. So the TCO is the first case. Is there a business case? How to range that? But I think there's also some concerns still on the market that can I really do the daily work with this fully electric tractor? What I need to do? If not, it's not a very good machine. So that's the same maybe as with the passenger cars in the beginning. A lot of doubts, and now it's quite much proven that it actually works and you can use them in your daily operation. So it's also this kind of an evolution that we need to start first, and then we may see this kind of snowball effect of increased
Do you think the battery autonomy is there to provide enough a full working day for these tractors?
For certain sizes, you also know we have the Fendt E100 as an ACGO fully electric tractor, the small one. So I think that can do the use case. So
yes,
no problem with that.
They are certainly out there. There's a few electric tractors coming, but they're a little bit of a rarity at the moment. But yeah, as you say, maybe it's something of a mindset as well as getting the technology right. And it does tie in, Mourad. You mentioned autonomous systems, autonomous vehicles. Does that go hand in hand? Do we need electric vehicles for them to be autonomous? Does that help with the design of autonomous systems? I mean, it seems like maybe it would.
Yes, certainly. And we do see it you can go on this fair and then everywhere. It's mostly goes in hand because actually autonomous systems they need to charge themselves, like for adding more fuel or actually products, as well as the smarts and the connectivity and the agility that they must have and the compactness. So all those plays a role in actually, mostly I would say 90% of the cases, autonomous is synonymous with electrification.
It helps. You're going to need electro-hydraulics, possibly even full electric actuators, which I've seen a few of those around the show. Maybe doing and this sort of partial hybridization as a step towards the full electrification. I don't know. Shaun told me about the Zoomlion combine harvester that they were showing. I don't know if anyone saw it. The concept with it's got rid of a lot of the belts, motors. You could probably describe it a bit better than me, Shaun. What they've done.
It's an interesting concept, and I think from an engineering perspective, it caught my eye that they've removed effectively all the belt drives and replaced them with direct drives from electric motors. So potentially a big efficiency saving, but certainly something as engineers, the engineer in you sees that and thinks, it just sparks the question.
It was interesting. I managed to get a video of it and a little walk around and zoom in on as many of the different motors as I could, and it was certainly creating a lot of attention, and people are very interested to see what they're doing there. But whether it works or not, I don't know.
Exactly, because what you're saying, it's a strong potentially, right?
Absolutely.
Because the efficiency of the belt drive is great.
Yeah.
And I mean, the most important point for a combine harvester is that it is reliable during the harvest. Yeah. So in the end, to have a, let's say, proven system with a high degree of let's say, reliability is of utmost importance for the farmer. Yeah. So we need to see, of course, it's super important to see these steps if they bring us forward. Let's see if we get the efficiency benefit that we're expecting or probably not expecting from such a solution, right? Let's see how it proves in the field. Yeah? And let's see if this is really creating the benefit that we're expecting from electrification. Because in the end, we're not electrifying to electrify, right?
No.
We're electrifying to reduce emissions.
Yeah. Yeah, and that has still had a diesel engine, of course. But they said it ran for 16 hours on the one tank. So due to the efficiency savings, so it was a very, very interesting machine, but not a fully battery, but using these motors, interesting electrification elements to it. Returning to batteries and battery chemistry, there's lithium-based batteries seem to be, the big thing, certainly in automotive, but they are starting to think about other chemistries. Let's go to. I'll put ACGO Power on the spot with your new because you've got a brand new concept battery system. What chemistry does that use?
So that's an NMC for energy density at the moment. So let's say in the future. So it seems in China there's a huge development with LFP, 5C charging in passenger cars already. Let's see if we get the energy density and also the energy per weight on a good level in alternative technologies. But currently our concept is relying on the NMC to really get as much energy on board as we can in the given space in the vehicle.
So that's to do with the energy density. That's
so that's really the key in agri applications at the moment.
Yeah. I'm sure you have some different options on your machines, don't you, for batteries?
Yeah, so I think we've said earlier, we launched our first hybrid machine in 2013, actually here at Agritechnica. We got a DLG gold medal that year, and it started our journey into an emissions-free product. So it took us until 2021 to really achieve what we wanted. And one thing we learned along the way, particularly there's a lot of caution, as we said. The total cost of ownership is one challenge. So we currently offer two options. We're fortunate with a materials handler that weight is not a problem. So we offer a full lead acid pack machine, which carries around 1,400 kilograms of batteries, and we offer the lithium option. Similar outputs in terms of performance, but one thing we've certainly encountered, one thing is the cost of ownership, also the full life cycle responsibility for the battery. And the lead acid product, of course, is today fully recyclable, whereas we still have a challenge in front of us with the lithium product as to where we go with that in the longer term.
So you're actually the lead acid is a popular option.
It's you would say at the moment it's the majority of the machines go out with the lead acid option. I don't see that being the long term,
no,
for sure. But actually, it's allowed a lot of users to make that step into that sector with a bit of peace of mind, I guess, would be the way I would describe it.
Yeah, and thinking about full sort of like life of machines and how we make things more environmentally friendly, which is the ultimate aim, really, of electrification and reducing emissions. Does anyone have thoughts on the component side and efficiency and recycling? And does anyone have any thoughts on any of that? I'm putting people on the spot there, but
So you mentioned the topic of recycling. This is for sure, let's say, one of the focus topics for the future. Yeah. So I mean, as of now, we are in quite a good position in Europe. According to Fraunhofer Institute, we have a capacity to recycle about 330,000 tons of batteries per year. And we currently see, let's say, the need for about 270,000 tons. So we're in a good position for recycling as of now. But as you may be aware, the first generation of batteries was mostly, let's say, assembled with screws and bolts, in a way that it's quite easy to disassemble and to separate. Yeah. Now, in the second generation of batteries that we see, this is all much more integrated. Yeah. And while as of now, the big challenge in the battery recycling is to, let's say, have a safe discharge of the battery before you start to dismantle it and to disassemble everything. In the future, for sure, the big challenge will be to separate the materials in the right way. Yeah. So Bosch Rexroth is very strong in this business from our factory automation side. We're doing a lot to prepare, let's say, after the first step where we are quite successful with the discharge processes, also with the disassemble process for the future.
Excellent. And from Danfoss?
I mean, just apart from recycling, it's also the extending the lifetime to also then have a second life of the batteries, maybe when it's first in the vehicles, but then also can have a second life in the stationary container and so on. So that's also possible. Not recycling, but extending life.
And thinking about going back to charging of these machines, you know, I suppose that's, you know, we touched on at the beginning of one of the big challenges that was sort of agreed upon was you know, and you can see it if you're a farmer out in the field, and you don't want to, like the range anxiety from, as we said, from automotive, you don't want to have to drive all the way back to the farm to charge it. Are there in-field charging solutions, or how can we address that?
That's a very good topic. I haven't seen it making its way to agriculture, but if you look to construction equipment, which has similar challenges, the industry is facing actually with that challenge and providing solutions. One of the solutions that is provided is BSSs. Those are big battery systems that you charge them somewhere and then you bring them, and then it provide you maybe 2 or 3 days of charging. So that's instead of bringing a tank of diesel, like you bring the power system. So that's one of the solutions that actually help with the range anxiety and provide the solutions for the challenge where infrastructure is not available in the field where the machine is being used.
In thinking about components again, I touched on electric actuators and replacing hydraulics, perhaps in large vehicles, so like in a combine harvester, perhaps an actuator that's a long way from a pump could be more efficient to do that without hydraulics. Would you say that's a possibility for the future?
Sure, possibility, yes. And I would say we see in Danfoss we see a journey, and electrification is still in the early steps, and therefore we are seeing a first step is to make it electric, meaning just to make an e-pump package, electric motor driving the hydraulic pumps. And then we see a lot of potential also in optimizing the hydraulic pumps, pump efficiency and valve efficiency, and then even go into recuperation, like over-center pumps who can also restore energy into batteries and so on. So we see a lot of potential in that system optimization part before going to electric actuators.
Yeah.
But I think the hydraulics are here to stay for a longer time, and one of the challenges that are there is the cost of the operation. So in these different machines, there are probably maybe a dozen or more of actuators. If you replace those with motors, that's a lot of motors. While with a distributed hybrid hydraulic system, it's much efficient and cheaper to build the system. And you can see Shaun agreeing with me.
I totally agree, because I think one of the things we've seen is it's all about efficiencies of scale. Yeah. So as a producer of machines that predominantly use a lot of hydraulics, the EV has to also use a lot of hydraulics to give us that affordability.
Exactly.
And our future direction will be that the differences between our fossil fuel powered products and our electrical powered products will be minimal. The power pack will be really the only difference. Yes. It will be the same architecture, the same structure, the same hydraulic design, but we need to focus from a TCO point of view and a customer to embrace the product. We need to make it as minimally different for the customer. So it's you know, we approach the product in a very modular approach, and that will give us that flexibility, I think, in the future.
Yeah. Is it actually possible to and is it desirable to simply take the engine out, put the battery in, and try and keep everything else the same?
Having tried it, no. Because I guess some of the component suppliers here in the room can probably understand that actually to rip out a diesel engine and put in an electric motor is not that straightforward. It doesn't work.
Okay.
It doesn't work. So there are some subtle changes, but I think one thing we're seeing as we grow, learn, develop, that actually some of our experiences are showing that there's a middle ground. We can find a compromise that works for both.
You don't have to change the whole thing, but there are some changes. Yeah. Yes, maybe we could talk about them. I'll come back to you, Mourad. We'll come over here to.
And for sure, that's quite a good point, which is also a focus topic for us. We bring together now new technology coming from the electric new side, with the, let's call it, conventional technology, the hydraulics, and the question is how to get the best out of it. So what we are working on is to develop specific pumps, specific hydraulic components, optimized for efficiency, optimized for noise, to be the perfect partner with the electric motor in the end. And not seeing them as standalone components, but operating them in an intelligent way together, yeah, having them always together in the best operation point, increasing the machine efficiency. Yeah. So what we can see, depending on the duty cycle, it's possible by optimizing the operation of both components to achieve up to 8% of efficiency increase. Yeah. Not for the complete machine, for the subsystem, yeah, but which is really, let's say, a great value in comparison to the small percentage points we can typically win on component optimization if you look at them in a singular way.
Maybe additional point for that. So in tractors, we will have a special challenge that even though the farmer would buy a new electrified nice tractor, there's a huge amount of old implements he most probably or she would like to use with the new tractor also. So we need to be able to provide the hydraulic power still. Maybe EPT also at the same time, electric power, but it needs to be compatible with all the old equipment in the farm also. So in all cases, we cannot get rid of the hydraulics and replace everything with electrics. So that's, I think, the special challenge in our case.
Yeah, yeah. Do you want to add to that?
I completely agree with the statement. And like if we see it from different industries, this is the first phase. Like the first phase is retrofitting, is yanking the combustion engine and replacing it with a battery and the motor. But I think to get the full use and a different case for the machine, I think you have to do a ground-up design. So first phase is everyone, like the first foray into electrification would be just a straight replacement, but I think ultimately, which will take more time, building grounds up to get much efficient machine for the purpose it's built.
We'll be getting there. You know, we've got alternative. I mean, this presentation is not about alternative fuels, but that is the sort of competitor almost to these electric machines, and maybe some farmers will be more comfortable with a methane tractor or whatever if they can get the fuel. Is there do you think there's going to be one or the other, or are we just going to have a mix of different low emission vehicles out there?
So maybe what you were just saying, yeah, we're not in a competition. Oh. Our target is to achieve emission reduction. Yeah? And the goal is to bring down the emission no matter which technology is, let's say, the leading one. Yeah? So depending on the application, it might be that a special engine technology will be the right way. It might be the case that electrification is the right way. It might be the case that we need to optimize the overall machine system to come to the solution that brings down the emission. In the end, this is the overarching target that we want to achieve together.
Yeah. And the pressure, as Shaun says, we probably need more government pressure. We probably need. I mean,
support, not necessarily pressure.
Not pressure, but regulations. Yeah. You know, I think there seems to be an appetite in the industry for this, and you know, people want to have low emission vehicles.
As a manufacturer, an OEM, it's frustrating that governments, while they make publicly a lot of noise about their commitments to a green future and reducing their impact, actually, when it comes to delivering for businesses, there's very little.
Especially infrastructure and other things.
Absolutely. And I think, you know, one thing we can say about electric today that we can't say about some of the alternatives, it's readily available globally. You know, there's many nationalities just here in the room and, of course, here at the show. You know, and that's one consistent thing we can say. If we want consistency, we can source electricity in every corner of the world. Where, you know, some of the alternatives, and I'm sure they will develop, and we will see. My belief is we'll see a very mixed future ahead of us with lots of alternatives, and it will take a number of years for one to become the predominant one. But ultimately, today, electric is readily available and, relatively speaking, cheap, particularly if you're generating it yourself.
Absolutely, yes.
And one very critical point regarding this legislative situation is that, are we really talking about well-to-wheel emissions or tank-to-wheel? Because if we are considering tailpipe emission of CO2, then the alternative fuels, whatever it's green, electricity-based e-fuels or whatever, it's not allowed if we get a CO2 reduction legislation based on tailpipe. So that's also going to shape a lot the technology part in the agri side, if there will be a tailpipe emission, or if we are really looking globally as a well-to-wheel, really taking into account the whole fuel manufacturing process.
Absolutely. This is where agriculture has been mentioned a couple of times. You know, the farmers are in this position where they have a lot of land. They can have solar panels, they can do biofuels. They could be a sort of ecosystem, within themselves, making their own fuel. It seems like a perfect opportunity, and hopefully one that can be seized. While they're thinking about, I am going to wrap up. I think I've got about 8 minutes or something. I think we're 55. What time? We finish at 55, do we? Is that the official finish time? Yeah, about then. We've got about 8 to 9 minutes. So if there's any questions, we'll come to the audience but shortly. But is there anything particularly that caught your eye, electrification-wise, so far here at Agritechnica? Have a think about that. And also, I'll ask as an additional question to sort of wrap up our discussion here about what's the future for electric vehicles? Where is this going? What's next? Near future, far future? However you want to answer that question. I'm going to ask all of you this one, and also think about anything you've seen at the fair, because a lot of us will still have some time to walk around and see a few more things. So any tips to go and look at? Markus.
I see a strong link for sure, autonomy and electrification, because electrification will enable autonomy also, because more precise control and so on. And we can also see here at the exhibition that many startup companies are also offering kind of autonomous electric vehicles, like smaller concepts. That's definitely I see. And then the full ecosystem, what you also mentioned about kind of rethinking the full farm infrastructure on energy and how to reuse business case and so on. So really drive that for optimization, kind of machine size and so on. Yep.
Yeah, it's very exciting. Excellent. Steffen?
With respect to the large machines, what we see is, let's say, rising interest in hybridization as an alternative, let's say, or a transition solution to reduce the consumption. Yeah. So this is a trend for sure. We have to look in and have to understand which benefit it really brings on the field. Yeah. This is for sure an important point. What in addition is quite important also, we see some kind of, let's say, transition from a first generation of electric equipment, let's say, more to a serious production-ready second generation trend. Yeah. We talked to a lot of customers saying there's a strong expectation that towards 2030, electrification will really come. Yeah. But of course, all the drivers we've been discussing here need to be considered and need to be part of the story. Right? So, and in the end, to get there, we need to bring the cost of the machine down. That will be a focus topic. Yeah. While of course the battery is playing a very, very strong role here. Yeah. And of course the overall machine architecture, the complete cost level of the machine needs to be brought down.
Yeah, it can be done, but
it can
be done, but maybe it just and it's being done now. But maybe at the moment the price point is a little high, and we need a little bit more help along the way. From Markus, I'll come to you.
Okay, so partly repeating the same. So what I've seen here in Agritechnica now is hybrid systems. We have one at our board, and our competitors are having them also on show. So that's clearly something that's under investigation at the moment. But for fully electric ones, so all the time energy density is increasing in the batteries, development is ongoing, and that will enable larger and larger agricultural vehicles to be fully electrified in the future. How fast? Let's see.
We'll see. We'll see. I'm Shaun.
I think there's two key words for me. One is affordability. We've already talked today about TCO and the entry into the electric product that has to be affordable. But convenience, as humans, we all like convenience. And, someone, I think Steffen mentioned the operator, and that's a key part of this as well. When someone's driven a diesel-powered product for a considerable number of years, they need convincing as well. It's not just the purchaser. You need to have the buy-in from the user, the operator. So, as an OEM, that's something we're looking quite closely on. And I guess myth-busting the perception that electric won't perform like diesel. Absolutely will outperform diesel, and this is the myth that we need to bust. It's got the power and the ability to go beyond what diesel can offer today.
Brilliant, and some of your machines doing that right now.
Yeah,
absolutely. Mourad.
A theme I have noticed across different OEMs is interconnected machines, smart machines, precision farming that is taking front stage in this edition of Agritechnica. Than previously, which is we have seen more battery electric vehicles in previous edition, but I think now it's like talking about more efficiencies, more things to be done now in the field.
Automation, a real trend as well, which goes hand in hand. So I don't know if anyone does have any questions. We've got one at the front straight away. Excellent.
Yeah, I think the three tractor OEMs have a massive amount of power determining.
Oh, we've got a microphone now, so everyone can hear. Here we go.
Thanks. Yeah, I was just going to say that I think there's 3 tractor OEMs that have a massive amount of power in determining whether we have electric tractors or not. And I think it's pretty clear for small tractors that it's the right solution. I think a lot of the technical things and even the cost of ownership, I think the biggest thing is actually the tractor manufacturers themselves have decided to go it slow because it's not in their business interests. And I'm just interested, how does it change the model for the tractor manufacturers, an electric tractor? Because I think this is, because of all these debates, we've been having this the last 10 years, like all the swappable batteries, for everything. It's going so slow. So how does it affect the tractor manufacturer's business model switching to electric tractors?
There we go. Good question, and a round of applause. Maybe we should put that way. Shaun doesn't build tractors, but we can talk to ACGO, absolutely. You're from ACGO Power, but I understand ACGO do also build tractors.
That's a very good and also very difficult question, maybe, and for me to answer also. So how does the business model change? So maybe not too much. We will anyway providing agricultural vehicles and tractors, combine harvesters. They will do the same work. So we will sell the machines, we will sell spare parts, maybe a bit less. In that case, if we are having less service for them. But I wouldn't say it's maybe changing too much. Of course, we could consider even concepts where the customer doesn't own the battery. It would be some kind of a monthly fee for the battery. Even maybe coming back to this earlier discussion that you may have different battery capacities and you may switch even at some point that, okay, now I want to have for these months a bigger battery and I will pay rent for that. That could be a significant change in the business model, that we would be giving just a tractor platform and then the battery would be for rent, for example.
It's a challenge to do multiple different things all at once, and not just making one type of machine, but many types of machines.
But the one thing we haven't touched on today is education and training, because you're moving into a realm that requires professionals involved for this, because we're dealing with high voltage. And as the car industry, automotive industry has moved towards it does require a huge investment across the networks to support those products. So, that's something that's a commitment as manufacturers, as OEMs, as the supply chain, and it's a big commitment. And of course, as a business, you've got to be able to see a return. So, I take on board your comments, but I think, that's why, like I said earlier, governments need to support this. They want a greener world. We need their support. We need their buy-in.
Absolutely.
Shaun, you didn't want to say that there are no professionals in the diesel agricultural machinery. They're working, they're training with electricity now, right now, so that's not the point. Yeah. My opinion.
Yeah, I mean, I would say so, but we're not seeing a quick enough take up, and the big problem we don't have enough professionals. Myself, I was a technician previously, so I've come from that background, and if I look at it from particularly a UK and Irish market perspective, we don't have enough young people entering the industry, so that in itself is a bigger issue. We're training people today, but they will grow older. That will move on. The technology will move. We need people that want to embrace that and work with it.
Excellent.
Other questions?
Testana?
Thank you. Xavier Mel from Kubota Engine Division. Thank you very much for your discussion. One point that I was listening is that you are considering electrification will come out only if there is support from the authority and legislation. But what I got from the experience of looking at the market, electrification in the agri-market is remaining, I would say, the last to come after automotive and construction machinery. And with this experience, we realized that electrification is not what the market is looking for. The sales is not as expecting. The sales in the construction machinery 5-6 years ago was today maybe 1/3 or half of what we were expecting. Now, with the experience that we have outside the agriculture market, one point that you brought up is hybrid solution. Why you didn't bring hybrid solution more earlier than today?
Okay, maybe I can take that one. So we are having quite specific operating cycles for tractors. Most of the field work is something where you are not braking actually. So this energy recuperation potential is not there in many of the use cases. For passenger cars lifting, raising things and putting them back in the ground, you can recuperate. That makes perfect sense in such applications. But that's really, we have high average loads, probably quite steady loads. So the hybrid system is not always giving you so huge improvements in the efficiency that it would be obvious that we will have a TCO positive case. So that's, I think, one of the key reasons operating cycles are not same as in some other areas.
Yes, hybrid, as you see, it's with the effect of recuperation of the energy. But one hybrid that we are not necessarily considering is that with the knowledge of electrification, more and more there will be electrical component for drive or for actuators. Yeah. And is to find hybrid, not necessarily with the big pack of power, but hybrid to give the power of all the electrical component that was brought to the market. And gaining the efficiency, because at the end, the need is to reduce the fuel consumption, the HVO, the fossil fuel, and gain on the efficiency of the machine.
That's a good point, and I mean the hydraulic efficiency is normally lower than the electric efficiency is higher, and therefore you can also think about like in big harvester machines where you have many kind of orbital motors which also are less efficient. You can also hybridize that, make those electric, and then you can also improve overall machine efficiency. And then you have one generator set on your machine, and then you can increase also have some benefit. Good point.
Good answer. Do we have time for one more question? And if there is one, we are nearly out of time. We got one more at the back. Just one minute left officially, I think.
Thank you very much for your presentation. I have until now didn't hear about the use of a robot, electrified robot for picking up the grab, for example. What do you think there is a future for this use case?
Certainly, for robotics is all over the world. Like there is more and more push. In different countries, there is less people present in the farms or the fields to work. So there is more robotization inside, like greenhouses, horticulture. There is more and more usage. So I think we see, like from our perspective, there is a lot more usage of robotic machines. So the future is very bright, and we are already mainstream there.
The future is bright. I think that's a nice note to end on. Thank you so much, everyone, for coming. On your way out, do pick up a copy of iVT. We've got several, I think you'll find Daryl out there. And you'll also find our cover star, Shaun Groom. He's right there with his new name, Max Power. No, that relates to the tractor. Yeah. But he is a powerful man, nonetheless. But thank you so much to all the panelists. Really great. Thank you.